Mozart had a huge production of music, and his very live presence during concerts made the whole experience quite unforgettable, as was his laughter. My bad, I'm sorry, my bad. I forgot to take my pills again. Now he would, for example, take that theme, that melody, and improvise over it live. Oh no, was that Tim's butt?
And welcome to another week and another webinar here at our live studio at Bridge Technologies. So if I just look around and do my best seagull impersonation, it's Hong Kong is 9 p.m, Atlanta is 9 in the morning, and it's 1500 here in Oslo.
That's so true, Tim.
Yeah, and we're following the ISM series. So the last couple of weeks we've been discussing what ISM is, and as Axel's just played for us, we have introduced production as one of the themes that we'll be going through today. So yeah, production is a bit of a hot topic at the moment.
Well, absolutely. You know, production has always been the start of any TV production, because again, it starts in the studio, in the venue, at the sports stadium, where everything is created. And you know, signal monitoring and analytics is just as important where the signal is created as in any kind of form of contribution and distribution. And we launched 1.5 years ago a new product, at least new for us, into the production sphere, which is called the VB440.
Yeah, great.
And the VB440 is quite substantial in its capability of giving you all these insights, especially for, of course, IP-based video. And we're very, very blessed today. So today we have actually Ståle, which is one of our lead engineers on this product, to show us this. And here you can actually see the interfaces. It's dual 100 gigabit interfaces. Right now it's currently receiving about 16 gigabit, which is quite a remarkable sum of data with a lot of different kind of streams. We'll select one of the streams and basically our services, to be correct, and a service, you know, that consists of a multitude of different flows. This consists of the dual video, because we got blue and amber, two different types of network with -7 protection, and of course two channels of audio as well. And typically you have a service consisting of up to 6 different flows. And here you can actually go into some of the flows to be able to actually see exactly what's going on. You have the media window, which shows you all the jitter characteristics, but you also have a very accurate display of all the packets that is being used. And this stream is about 1.5 gigabits per video stream, basically. So here you can go and have a deep look. You can also, of course, capture some of the packets if you like, and you can choose whatever flow or all the flows if you like to capture, and it's just a click of the button, and there you actually have a nice PCAP you can open in your Wireshark. You can also go very, very detailed into all the different timing of the individual flows within the service to be able to qualify. Is it a narrow transmitter? Maybe it's a wide transmitter, or a wide and narrow transmitter, to really make life complicated. And you can go into sub-microsecond accuracy to see individual questions of timings, so that you can get real objective fact about the buffer fillings, so that you can again pair the right equipment with the right equipment. That's some of the features we have. And of course I mentioned -7, and of course we can go in and take a look at the different streams, evaluate that up against each other, and see then the variances. Because as we all know, -7 doesn't really mean anything if it's too skewed. Then basically the protection mechanism has no real value. You can do this for the video, you can do this for the audio, and of course for the ancillary data if you like. And the key thing, we don't have any ancillary data on that one. Sorry, that's my mistake. And of course you have all this beautiful metadata on how the individual streams behave, so you can see errors in the packet transport, and you can also see errors that inflict damage to you. So if you have then errors on both streams that disables the ability to recover, you will also see that. In addition, in this tool, we also have the traditional, of course, video waveform scopes. We have, of course, the waveform scope in different variants, the normal, nice vector scope, and of course, we also implemented the diamond scope for those of us that loves that beautiful old technology. We also monitor, of course, the audio. You can listen to the audio if you like, and actually then validate that there is audio. We can do that up to 64 channels, basically, per service. Actually, no, that's not true. It's 64 channels per flow, actually, so you can have a practically unlimited amount of channels per service. So this gives you, and of course I forgot, but we don't have a lot of ancillary data to showcase, but we do have very, very advanced ancillary analytics capability, also with SCTE 104 actually. So the key thing here is that it's a lot of capability in this, and as you've probably seen, it's very, very responsive, very, very fast to work with, and everything you see here is coming from a web browser, because from 16 years ago, every single product that we made with web interface, and that of course enables you to do this from anywhere on the planet, and that means of course that all this that you see now in full real time is remote capable, which is absolutely important in these days. So I believe that was some of the features
it was,
of this
and
one.
I've actually been allowed to sit in Philip Burnham's seat this week.
Yes.
So we swapped sales to marketing, so I won't miss an opportunity, but I think we have been given some badges for that.
Well, that's very true, because we've been part of the joint task force for network monitoring, and was also given the opportunity of be one of the vendors to qualify all the other vendors within this scope. And it's very important to have these very accurate analytics equipment, because right now, as we know, ST2110 is still kind of in early days for most of people, right, because they're not used to actually dealing with this extreme bandwidth, this extreme demand of accuracy, and of course everything going over IP, which is still very new. Yeah. So, we've been blessed with the capability of helping out.
That's right. Yep.
On that, of course, both for the ST2110 different variances, but also for, of course, all the AMBA specifications in NMOS.
That's right. Yep. And we'll probably go into a little bit more in depth in another webinar.
I believe so.
On these things, but yes, that's it's great recognition for the VV440. Now we're going to introduce a new little theme, which is to explain why is this important.
Oh,
Simen,
yeah.
Do you want to?
Well, absolutely. First of all, it's not a very smart thing to go into anything blind. You know, if you have an SDI cable, a coaxial SDI cable with a digital signal, you usually plug it into a monitor and you see the signal. You usually plug it into a waveform vector scope and see that, oh yes, it's within limits, it's very fine. But with IP, we introduce something that is pretty organic. So it's not like you need to just test and see, oh, it's fine, yeah, and then disconnect it. No, you need to look at this thing all the time because it varies. And that is the most important thing with IP analytics and monitoring, that you have to do it continuously and all the time.
Yeah, readily available, yeah. No, absolutely. No, that's great, and a great little snapshot of an amazing product. But I think probably we should move on to the next section, and we're going to hear again from our friend Axel Kolstad.
The beauty of contribution is that you can listen to me, Mozart, anytime you want from wherever you want. Now, that was not the case during the 1700s. But I can easily picture Mozart playing, thinking he was all alone, and then realizing that he was on Netflix being watched by millions.
He has an amazing laugh, Mozart, and some fantastic playing there. So yeah, so another little section that we thought we'd look at in the ISM chain of things is contribution.
Yes.
Again, if we Want to say a little bit about that, or we can hop over straight to demoing?
Yeah, absolutely. Contribution is a key element in everything that you do, because most of the things that you produce is not often just on tape or basically on a server somewhere. It's coming from a stadium near you, it's coming from a venue outside of your broadcast facility. And of course, it's very unpractical to transfer many times full uncompressed signals towards your studios. So you utilize different kind of methods for that. And most of the methods that has been utilized, and here we're going to lean on our friend Ståle again. Most of the things that we utilize there is transport stream encapsulated services. We're showcasing some of our great stuff that we can do in our transport stream analyzing capabilities. We have a full ETR 290 a deep analyzer where you can go in and basically find out nearly anything about your streams. Typically today, it's very popular with SRT streams, which again is of course transferred over transport stream, and also JPEG 2000 streams. Coming is of course JPEG XS, which can be either transport stream encapsulated or basically transferred over the same mechanisms as ST2110. But the key thing here is again that we're ready for it. We have all the tools to be capable of monitoring this with very, very high degree of accuracy. So I believe that showcases some of the importance when it comes to the transport streams, how you can utilize the same set of tools to look at production, to look at contribution, and of course the faceted, not to forget, distribution part.
Yeah, well, I mean, drop packets jitter is a problem in all facets, production to contribution.
Absolutely, because again, you need to make sure that all your media has the same integrity going through all the different chains down towards the end user. Breakdown in one of those links will, of course, create problems.
Yeah, and I guess ISM is an effective way to not, to follow everything and not break those.
Yeah, because ISM is basically saying that this is integrated services. You should look at all the contribution links together with the production links, and basically all the way down to again the end user, and that's when the real value occurs, when you can utilize, again, the same type of tools to look at all these different types of signals.
That's right. Now, I think we've explained a little bit of what we were talking about, but we're going to go again to our theme, and it is, why is this important?
Well, I believe some of the things that contributes to most of the importance is the ability to have your users utilize the same tool for different purposes. Yeah. First of all, you don't need to train them in all these extreme width and variances of different types of signals. You have, again, one majority of philosophy behind all this. And of course, it needs certain variances because all the signals are different. But again, you can utilize the same equipment, so you don't need to reinvent the wheel every single time you are faced with some errors in some weird kind of signal characteristics. Yes. And that, I believe, is one of the most important.
Yeah, and I guess that's another good thing with the VV440. Which is one of the newer products for production, but it's based on the same code as same products that we use in contribution.
Very true.
So we can rely on that sort of sort of expertise. That's brilliant. Now I think we should add a third section in, but first we will hear from our friend again, Axel Kolser.
The distribution of Mozart is sort of like using different cables, not testicles, terrestrials, and satellites as vehicles. Now, in this case, you chose me. And that's on you.
So moving on to distribution, as you've just heard from our piano player, another very important part of ISM, and another one that we're focusing on today. Do you want to explain a little bit about the distribution part of ISM?
Well, you know, traditionally distribution was what everybody in the public understood as broadcast, because that was actually the name, you know, broadcast. We're broadcasting this signal. They didn't care so much about the production and the contribution. It was just a distribution to the masses looking at these fantastic shows. And of course, the first one was terrestrial, because it was a huge transmitter and that spread out the signal. And then, of course, came satellite. And then came, of course, cable, which was amazingly popular. And cable is now the biggest venture for getting internet into people's homes. So that has been, you know, extremely successful. And of course, the last 10 years, we've seen a dramatic revolution in how media is delivered via OTT. And OTT comes in a multitude of different flavors. HLS is, of course, by far most prolific. But then we have Dash, we have smooth streaming. We had another couple which was not that successful. But the key thing is that monitoring OTT is, of course, one of the key important things. And I'm going to lean to my colleague Ståle again to basically help us to showcase. Yeah. And here we see one of our active OTT agents or engines, if you like. And we can go into one of the HLS streams and actually have a look on all the different profiles. Here you can see all the behaviorisms for all those 4 different types of profiles that has been going on for the last 4 days. And you can also go into more detail if you like. You can have a look at, let's say, the descriptor file, basically, which is the manifest, because usually or many times it may not be in the physical media itself, but the metadata explaining about how the media should be basically utilized, that there is an error. Here we can go into any kind of detail on the metadata following that media chunk that is being delivered to your phone, your set-top box, whatever you actually are going to utilize to watch it. And we have the capability, of course, to go into even more detail. We have a lot of preset types of alarms, which then you can go and post-evaluate if it has been broken. Because, of course, we give alarming immediately if some of these, both metadata, the media chunks, is not in coordinates with the standards. And here you can also see the historic data on that. You have also the capability of course, decoding the physical data with all the different type of variances within the different profiles. And you can also do a compare within the profiles to see alignment, to see when each individual profile actually let's say, resynchronizes on the origin point. This particular probe is actually standing on the origin point where it's being held before it's distributed to the various CDNs. But you can utilize the same exact mechanisms as this towards then a pre or post CDN kind of scenario where you want to then monitor the different CDNs just to make sure that you know exactly what's going on. Thank you, Ståle, for an excellent demonstration.
And I guess there's a lot of subscribers at home, well, since March really. We don't have to state the bleeding obvious, but OTT has been, yeah, an important factor.
Oh yes, and OTT is by far going to be one of the absolute most important distribution forms. It already is. We've seen an SVOD market that basically has grown beyond any expectation. And of course, we've seen utilization of media that is only doable because of OTT. So the media landscape is changing dramatically, and we like to think that OTT is a big contributor to that. And OTT has been a very, very important part of our monitoring history for quite some time now.
OTT engine was
yes,
yeah, one of those bases. We're actually going to go into OTT in a little more in depth next week. That's going to be the next Tuesday's topic, so we won't go into too much.
Thank you very much, Tim.
That's right, but I thought just one more. This is what Norway looks like from about November to February. A bit of a snowstorm there, so it's not. It's 28 degrees and lovely weather. So thanks for joining us here in Oslo at our live studio with Ståle, who has been demoing, Simen, who of course is a regular on the show, and thank you for myself, and thank you for watching. We'll see you next week.